So in this video we're going to look at an application where we model traffic flow using matrices. So here I have an image of or a model of a set of one-way streets. So this street here we have traffic flow moving this way, and on this street we have traffic flow moving this way only. And then the intersecting streets here are also one-way streets with the arrows indicating the direction of flow along the streets. And then the basic principle we have is that cars are going to be flowing into and out of intersections. And the big idea is that if traffic flows into the intersection, it has to flow out of the intersection unless there's a wreck, right? So the total number of cars coming in should equal the total number of cars exiting any given intersection. And then the problem is to determine or model the traffic flow along each of the roads. And usually what we're trying to do is figure out what's the highest and lowest the traffic flow can be along any given arterial. So we want to model the traffic flow for each of four streets that are depicted here in this image. And so we don't know the traffic flows along these four streets, but we do know the traffic flow either coming into or flowing out of each of the four intersections that connect those streets. So what we do is give each street a variable name. So let's just say, hey, this is road number 1, this is road number 2, here's road number 3, and here's road number 4. And we want to model the traffic flow along each of those four roads. And then we use this basic idea that if traffic comes into an intersection, it has to exit the intersection. So here, for example, you see road 1 and road 2 each flowing into this intersection, and we have cars then flowing out of the intersection. Well, the total number of cars exiting the intersection has to equal the total number of cars coming in. So if road 1 and road 2 represent vehicle flow, this is in vehicles per hour coming into the intersection, then what we know is that the vehicles per hour coming into the intersection, the vehicle flow on road 1 plus road 2, has to add up to the 400 plus 350 is 750 vehicles per hour flowing out of that intersection. Similarly here, this intersection has 600 plus 400 is 1,000 cars per hour flowing into the intersection, and road 1 and road 4 flow out. So R sub 1 vehicles per hour plus R sub 4 vehicles per hour has to add up to the 1,000 vehicles per hour flowing into the intersection. And then this intersection here, we've got 500 plus 400 cars per hour flowing into it, so a total of 900 cars per hour flowing in. And roads 2 and 3 flow out, so R sub 3 plus R sub 2 plus R sub 3, R sub 2 plus R sub 3 vehicles per hour have to add up to the 900 vehicles per hour that are flowing in. And here we have 1,150 vehicles per hour flowing out. We take the sum of these two units, outward flow, and we have road 3 and road 4 feeding into it. So the total cars per hour from road 3 and road 4 have to add up to the 1,150 vehicles per hour flowing out. And then that gives us then four equations with four unknown flows, right? We have four unknown flow rates. So we have four equations, so we have a system of equations set up. Now we just need to move it into matrix form, where we let the columns represent the unknown flows along each of the four roads, and then we have the augmented matrix with the constants column here. So this one says 1 road 1 plus 1 road 2 equals 750. So we get 1, 1, no road 3, no road 4, 750 cars per hour as our constant. Here I have 1 road 1 plus, there's no road 2, no road 3, 1 road 4, adding up to 1,000 vehicles. And here we have no road 1s. We have 1 road 2, 1 road 3, no road 4s, and 900 vehicles per hour flowing out. Make that matrix just a hair bigger. And the last equation says there's no road 1, no road 2, 1 road 3, 1 road 4, adding up to the 1150. So now I have the matrix that models my system of equations. That's modeling my traffic flow on this road setup. So now I'm going to keep that and escape out to GeoGebra. We'll get a new window going in GeoGebra here. And options, let's see, options, font size, let's put that font size up a little bit larger. And view, we're going to go into our spreadsheet view like we've been doing, and then we need to put our matrix into the spreadsheet. So our matrix is, the first row is 1100750, so it's going to be 1 tab 1 tab 0 tab 0 tab 750, enter. And then the second row is 1 tab 0 tab 0 tab 1 tab 1000 vehicles per hour. Row 3 is 0110900, so 0 tab 1 tab 1 tab 0 tab 900, enter. And row 4 is 00111150, so we have 0 tab 0 tab 1 tab 1 tab and 1150. So we move our matrix off our scratch paper into GeoGebra, and like we've been doing, we left click and highlight the cells. We right click to bring up the context menu. We create a matrix, and then once we've created that matrix, we want to put the matrix into reduced row echelon form and then interpret the results. So I'm going to rename this matrix. This is my traffic matrix, so I'll use capital T. And in view, I'm going to open my computer algebra system. I'm going to type in reduced row echelon form to bring up the function. I'm going to input my matrix T. So I input my cap T into the function and hit enter. And now GeoGebra gives me my matrix in reduced row echelon form, and it's up to me to interpret the results. So let's open up a pen tool here so I can write on top of GeoGebra. So remember, each column represents the roads, road 1, road 2, road 3, road 4. So this here says 1 road 1 plus 1 road 4 equals 1,000. This guy here says 1 road 2 minus road 4 equals negative 250 from right here. And this says 1 road 3 plus road 4 has to equal 1150, and the last row is all 0, so I don't need to do any interpretation there. And then what we want to notice is that road 4 shows up as a variable in each of these. So I'm going to solve each equation in terms of road 4, because road 4 is going to be kind of the controlling factor or the controlling road in this particular case. Clearly what happens to road 4 impacts each of the other roads in the system. So here, subtract road 4 from both sides is going to give us road 1 is equal to 1,000 minus road 4. Here, add row 4 to both sides is going to give us road 2 equals, adding road 4 to both sides, we get road 4 minus 250. And here, subtract road 4 from both sides, we get road 3 is equal to 1150 minus road 4. And then the job is to identify what the traffic flow looks like across each of the roads. And what we need to do is kind of carefully analyze what's going on with road 4. So for example, if we hone in on this relation right here, we have road 4 minus 250. Well, the flow on road 2 can't be negative. These are one-way streets, and the only way a negative would make sense is if we were allowing travel to be going both ways. So this number, road 2, is a measurement of vehicles per hour flow. It can't be negative. So the lowest it can be is 0. And what we see here is if we plugged in 250 vehicles per hour for road 4, we'd get 250 minus 250 is 0. And 0 would be the lowest flow rate that road 2 could have. So road 4, I can start to hone in on its domain. Where is it allowed to be? The lowest it can be is 250. If we go below 250 cars per hour, we get a negative flow on road 2, which isn't possible. And if I look at the other two equations, I'm going to see that it puts a maximum on the flow rate for road 4. Because here, if I go over 1,000 cars per hour, I would get a negative flow rate on row 1. Road 3 could handle road 4 having 1,000 cars per hour and still be positive. Road 3 could go all the way up to the 1150 before we would start getting negative numbers. So we're going to have to use the most restrictive parameter here. So road 4 can't exceed 1,000 or we get negative flow on road 1. So road 4 is going to have to range somewhere between 250 vehicles per hour and 1,000 vehicles per hour. And once we know what road 4 can do, we can identify what's possible on the other roads. Road 1. What are the outputs that are allowed for road 1 for vehicle flow? Well, if the flow rate on road 4 is at its maximum of 1,000, we get 1,000 minus 1,000 is 0. We get no cars traveling along road 1. And if the flow rate on road 4 is the lowest it can be, the 250, then we get 1,000 minus 250, which is 750, is going to be the largest flow rate we get on road 1. And then we can make the same analyses for the other two roads. Road 2, where can it range? Well, the smallest it's going to be is if we have road 4 at 250, we'll have a flow rate of 0. And the biggest it will be is if the flow rate on road 4 is 1,000, we'll get 1,000 minus 250 is 750 cars per hour. And road 3, where can it go? Well, the smallest it will be when road 4 is the biggest it can be. So 1150 minus the 1,000 right here. 1150 minus the 1,000 would be 150 would be the smallest it could go. And the biggest it's going to get is when road 4 is the smallest it can be, which is 250. So 1150 minus 250 is that 900. So the largest the flow rate will be along road 3 is 900 vehicles per hour. So what you can see is you would really need to, if you were trying to figure out what was going on the other roads, roads 1, road 2, road 3, you would really need only to hone in on and analyzing the flows along road 4, because as soon as I know what the flow rate is on road 4, I will know what the flow rates are on the other roads.